Hello students, in this video I explain important remaining continuity problems. See, observe here. See, if f of x is equals to log x divided by x minus 1, if x is not equals to 1, k if x is equals to 1 is continuous at x is equals to 1, then the value of k is. See, now here to solve this problem, we use the definition of continuous function because the given function is continuous at x equals to 1 is given. That's why now here we use the definition of continuity. See, limit x tends to, see here at the point at x is equals to 1, x approaches to 1, f of x is equals to f of 1. This is definition of continuous function at x is equals to 1. Now here we have f of x function log x divided by x minus 1. Now right, this result can be done as x approaches to 1, f of x is log x divided by x minus 1. At x is equals to 1, f of 1 is equals to k. See, now x approaches to 1. See, here we substitute 1 in the place of x. See, log of 1 is 0 divided by 1 minus 1, 0. See, here we get 0 by 0 form. Here we apply L'Hospital rule. L'Hospital rule states the derivative of numerator, derivative of denominator. Limit x tends to 1, log x is 1 by x divided by derivative of x is 1, constant term is 0. 1 minus 0, right, 1 is equals to k. Next, this implies limit x tends to 1, 1 by x is equals to k. Now here x approaches to 1, we substitute 1 in the place of x, we get 1 divided by 1. K is equals to 1 divided by 1 is equals to 1. Option C is correct. Here we have second example. F of x is equals to mx plus 1 if x less than or equals to pi by 2, sin x plus n if x is greater than pi by 2 is continuous at x is equals to pi by 2. Then here we have options, 4 options. Now here we check which option is correct. To solve this problem, we use the definition of continuous function at the point x is equals to pi by 2. Here we have the conditions less than or equal and greater than condition. Now here we use the second definition, left hand limit and the right hand limit result. See, limit x tends to pi by 2 minus left hand limit f of x is equals to limit x tends to pi by 2, left hand limit less than condition. Here we have the function mx plus 1. X approaches to pi by 2. Now substitute pi by 2 in the place of x. We get m into pi by 2 plus 1. And this result is also is equals to f of pi by 2. Next, consider right hand limit. Limit x tends to pi by 2 plus f of x is equals to limit x tends to x approaches to pi by 2. Here we have function f of x is sin x plus n. Sin x plus n is, see, x approaches to pi by 2 means substitute pi by 2 in the place of x. This result becomes sin of pi by 2 plus n. See, sin of pi by 2 value is 1 is equals to 1 plus n. This is a right hand limit function. Now here using data, by data f is continuous. See, f is continuous means continuous at x is equals to pi by 2. See, function is continuous means left hand limit is equals to right hand limit. Here we have left hand, see, left hand limit, this value is right hand limit and also is equals to f of a, here f of pi by 2. See now here by data f of x means f is continuous means left hand limit is equals to right hand limit is equals to f of pi by 2. Now we are using this definition left hand limit value is m pi by 2 plus 1 is equals to right hand limit value is 1 plus n. See now here both side plus 1 gets cancelled. This implies n is equals to m pi by 2 is the required solution. Option C is correct. So here we have the function given by f of x is tan x is discontinuous on this set. Here we have four options here, n pi, 2n pi, 2n plus 1 into pi by 2 and n pi by 2. Now observe, we know the concept. Tan of 90 means tan of 90 degree, pi by 2 value is not defined, undefined form. See now here we have option, say in the form of n pi by 2, n belongs to z. N belongs to z means integers we consider. N is 0. Suppose we consider n is 0. 0 into pi by 2 we get 0. So this is a possible form in that result. But in option C, observe 2n plus 1 into pi by 2. See n is 0. In that condition also it satisfied. N is 0 means 0 plus 1 is 1. 1 into pi by 2 is pi by 2. Tan of pi by 2 is not defined, means it is discontinuous on this set. That's why option C is correct in this result. See next example. If f of x is equals to x plus 1 whole to the power cot x is continuous at x is equals to 0, then f of 0 is equals to, here we have four options. Here we have to check which option is correct. Now here by data, f of x is continuous at x is equals to 0 means limit x tends to 0, f of x is equals to f of 0. So now here we have f of x function. Therefore limit x tends to 0. Alright. First f of 0. F of 0 is equals to limit x tends to 0. Substitute the value of f of x is x plus 1 whole to the power cot x. Next, see now in this result x approaches to 0. Since x approaches to 0, substitute 0 in the place of x. We get 0 plus 1 is 1. 1 to the power cot of 0 is undefined form. 1 to the power infinity. Now that's why otherwise this result can also be written as cot x can be written as 1 by tan x. Say this right here, limit x tends to 0, x plus 1 to the power cot x can be written as 1 divided by tan x. 1 by tan x. Next, here I multiplied and divided by x. See, because we know this standard result, x tends to 0, x by tan x or tan x by x is equals to 1. That's why I rearrange this result. Multiplied and divided by x. 1 into x is x, divided by x. Next, this result can also be written as the limit x tends to 0, x plus 1, 1 divided by x form, alright, whole to the power x by tan x. Next step, now x approaches to 0. Say x approaches to 0 means, see here we have one term is x plus 1 to the power 1 by x, another term here we have x divided by tan x. Now apply limit both terms, f of x to the power g of x. Apply limit here, substitute 0 in place of x, here we get 1. See 0 plus 1 to the power 1 by 0. Again that results form, but here we have standard result 1 plus x. We use this result. See here instead of this result we can write 1. Standard, this is in the form of a limit x tends to 0, 1 plus x to the power 1 by x is equals to e to the power 1 or e Now here, this is standard result. Now this result can be written as E. Then limit x approaches to 0, x by tan x, this value is 1. This is equals to E. Option C. See, this is the required option for this result. So here the value of b, for which the function f of x is equals to 5x minus 4, here 0 less than x less than equals to 1, 4x square plus 3bx 1 less than x less than 2 is continuous at every point of its domain is minus 1, 0, 1 and 13 by 3. See, the function is continuous at every point of its domain. See, f of x is also continuous at x is equals to 1. Therefore, f of x is continuous at x is equals to 1 means limit x tends to 1, f of x is equals to f of 1. Means here x is 1, what happens? F of 1 is equals to 5 into 1 minus 4. 5 minus 4 is equals to 1. Say this value is equals to 1. Now here we have less than and greater than condition. Here we have to use left hand limit and right hand limit functions. Then here we have to find the value of b. See now here apply left hand limit. Left hand limit, limit x tends to 1 minus f of x is equals to limit x tends to 1. F of x, see, less than result is 5x minus 4 is equals to x approaches to 1. Substitute 1 in the place of x. 5 minus 4 is equals to 1. Next, right hand limit RHL is equals to limit x tends to 1 plus f of x is equals to limit x tends to 1. Here we have less than, see here x is greater than 1 means right hand limit function 4x square plus 3bx. Here x approaches to 1. Substitute 1 in the place of x. 4 into 1 square is 1. 1 into 4 is 4 plus 3b, x is 1. 3b into 1 is 3b. So this is right hand limit function. Now here f is continuous at x is equals to means left hand limit is equals to right hand limit is equals to f of 1. See, left hand limit is equals to right hand limit means left hand limit is equals to right hand limit is equals to f of 1. See, this implies, see 1, left hand limit is also 1, right hand limit is 4 plus 3b. 4 plus 3b right is equals to right hand limit value, left hand limit value, and f of 1 is also 1. This implies 3b is equals to 1 minus 4. See, 1 minus 4 is minus, we get minus 3. 3b is equals to minus 3. Divide both sides by 3. This implies b is equals to minus 1. Option A is correct. So here we have the function f of x is equals to ax minus b, x less than equals to 1, 3x, 1 less than x less than 2, bx square minus a, x greater than equals to 2 is continuous at x is equals to 1 and discontinuous at x is equals to, see, function is continuous at x is equals to 1. See, f of x is continuous at x is equals to 1 means limit x tends to 1, f of x is equals to f of 1 using the data. Say function is continuous means left hand limit is equals to right hand limit at the point x is equals to 1. Left hand limit is equals to limit x tends to 1 minus f of x is equals to limit x tends to 1, f of x, see, x less than condition, left hand ax minus b. Ax minus b is equals to, see, here we substitute 1 in the place of x, we get a into 1 is a minus b. Then similarly find right hand limit is equals to limit x tends to 1 plus f of x is equals to limit x tends to 1. See here x is greater than 1 form, here is a 3x. 3x is equals to 3 into 1 is equals to 3. Next, see, by data, f of x is continuous at x is equals to 1 means left hand limit is equals to right hand limit is equals to f of 1 means here a minus b is equals to 3, or this implies a is equals to 3 plus b. A value is 3 plus b. Next, here we have one more, and also here discontinuous at x is equals to 2. Discontinuous means f is not continuous. F is not continuous at x is equals to 2 means limit x tends to 2, f of x is not equals to f of 2. Now here find left hand limit. Limit x tends to 2, say x is less than 2 means 3x. 3x is equals to, substitute 2 in the place of x, 3 into 2 is equals to 6. Next, right hand limit is equals to limit, see here we consider directly the result x tends to 2. Here consider limit x tends to 2 minus f of x is equals to, then substitute the f of x is 3x. I consider directly right hand limit x tends to 2. Here we have bx square minus a. Substitute x is 2. b into 2 square is 4. 4b minus a. See now here data f is not continuous at x is equals to 2. Supposing left hand limit is equals to right hand limit means supposing left hand limit is equals to right hand limit, here we get 6 is equals to 4b minus a. See 4b minus a, or 4b is equals to 6 plus a. Now we know the value of a. A is equals to 3 plus b. Now substitute the result is equals to 6 plus 3 plus b. Otherwise I write directly here 6 is equals to 4b minus a value is 3 plus b minus 3 minus b minus 3 minus b. Then 4b minus b is 3b. This implies 3b is equals to minus, here we have minus 3 is minus 3, take to left hand side we get to plus 3, 6 plus 3 is 9. So now divide both sides by 3, we get, this implies b is equals to 3. See b is equals to 3 when the function is continuous, but here f is not continuous means f is discontinuous at x is equals to 2, but b is not equals to 3. See here here we get that b is equals to 3, but using by data f is not continuous, that's why here we consider b is not equals to, right here b is not equals to 3. b is not equals to 3. Observe here we have option C. See a value is 3 plus b and discontinuous b is not equals to 3. Option C is correct.